for today, first of all, before we get started on anything, we have to understand what we're doing. Because making ice cream is fun, but we need to understand the science behind it, right? So what do you guys, who's done this before? Okay, in a bag, or how did you make it?
I think it was Girl Scouts in a bag.
In a bag, that's pretty common. Okay, has anybody else made ice cream before?
I made ice cream in an ice cream maker.
In an ice cream maker, okay,
Yeah.
good. Ice cream maker, okay. Any other ways you made ice cream?
Yeah.
You know that ball?
Oh, that ice cream.
The ice cream ball?
Like the soccer ball that you beat with your foot and
Yes.
break all your toes?
Beat it.
Yes, you can kick the ball. Mariah, what were you saying?
I just
You what?
I don't know. I don't remember. I made it in like a pot though.
Yes, there's a lot of different ways to make ice cream. You can do it that way, and then you freeze it. So, you guys just named off like 5 different ways to make ice cream. And then you can always just go to the store
Buy ice cream.
and buy ice cream. And is there just one flavor?
No.
No, there's so many different flavors. Do they all taste the same?
Formulas.
They all taste different, right?
Yeah.
Why do they all taste different?
There's put different things in them.
Yeah, there's different things and different techniques. So today we're going to talk about some of this. This is also going to be for the friends who are at home online. I'm going to share this video with them. So think about that and what they're doing. They have a list of ingredients at home if they want to try this at home, but I'm going to be videotaping you guys making it and discussing some of it to share with our online friends, because half the class is at home online. Just keep that in mind as we're going through all this, okay? Any questions about that? No? Thanks, guys. Okay. The science behind ice cream in a bag. So, today, I am learning. Will somebody read this out for me?
I am learning that water can exist in different states. Ice is the solid state of water.
And what is our success criteria for today? Sophie.
I can explain that
Properties.
physical properties are characteristic of the substance. They do not change. Physical properties include color, smell, freezing point, melting point, and density.
Awesome. And Zaylin, the next success criteria.
The bottom one?
Right here.
Oh god, I can explain the freezing point of water is the same as the melting point of ice.
So the freezing point is the same as the melting point. So by the end of class today, we'll know more about this, right? You'll understand more about this?
Okay.
Okay, and another thing we're gonna learn today, Taven.
I can define endothermic,
Good.
exothermic, and freezing point.
All right, so we have a few vocabulary words we need to go over. Endothermic, exothermic, and freezing point. So you're gonna know what that all means. Some of you may know, some of you don't. So we're gonna make sure everybody understands, okay? So we're gonna explore the science of making ice cream in a bag. These are the definitions by the end of the class I want you to know. Endothermic, exothermic, freezing point, and compound. If you would like to write those down in your notes, and then as we go through the notes, you can write in the definitions. And then we are going to put this to the test. We're actually gonna see these in action by making our ice cream, okay? Thumbs up or thumbs down? You guys okay? All right, any questions so far? All right. Do you guys all have the vocab words written down?
No.
Okay. Take another minute, write down the 4 words. Endothermic, exothermic, freezing point, and compound. We will be providing definitions for these very soon. If you guys have heard of these terms before, can you show me a thumbs up? Thumbs down, if they're all brand new. Okay. 2 thumbs down, you have no idea what I'm talking about? Okay, all right. Very good. By the end of class, I hope everybody's a thumbs up, so that's awesome. Thank you for sharing. Okay, so endothermic, exothermic, freezing point, and compound. So we talked a little bit about this already. What do you know about ice cream? What do you guys know?
Ice cream.
It's tasty. What else?
Dairy.
Dairy. What else?
Different flavors.
Awesome. Different flavors. What else do you guys know about ice cream?
You have to put
cold.
It's cold.
bonding agent in it, don't you?
There has to be some kind of bonding agent. Okay, what else? What's in ice cream?
Milk.
Milk, chemicals, cream. What else? Ice.
Cold.
Vanilla, if you like vanilla.
Ice cream salt.
Ice cream salt, sugar. Okay. So, have you ever thought about as you're eating ice cream, what's in it? Or you just eat it because it's yummy?
I see because
Yeah, lots of us, right? This is yummy, I'm gonna eat it. And does anybody have a favorite ice cream? A favorite like Ben and Jerry's or Dairy Queen, or who has a favorite ice cream? What's your favorite?
I like the half baked one.
Ooh,
It tastes so good.
yum. How about the rest of you guys? What do you like about it? It's mostly the taste or texture, or
It has brownies in it.
brownies are always a bonus. What do you guys, what's your favorite ice cream?
I like coffee flavored.
Coffee flavored. And do you have a certain brand you like to buy from, or doesn't matter? Does anybody have a favorite brand, or it just doesn't matter?
Dairy Queen or Ben and Jerry's?
Dairy Queen or Ben and Jerry's? Gyres, there's Bluebell, there's, I can't think of all the ice cream right now.
I don't like that one ice
Your
cream that
local
you get,
King
like, a
Supers
huge
brand.
tub.
Why don't you like it?
I don't know.
Like the Kroger brand?
Why is it the quantity that scares you?
It's that big, it's a nice big plastic tubs, right?
Yeah.
Is it texture, or is it flavor?
I don't know, it's not good.
Okay, so be thinking about that today, because this all goes back to science. The way your ice cream tastes has to do with science. So be thinking about what you like and you don't like when you eat your ice cream, and what we can do maybe to make it different, or what could have been done, or how it was processed. I want you to really be thinking about ice cream in a whole new way, okay? So you need to think about how you make it, what ingredients are involved. We have a little article here, ice cream, what do you know? So this is a pretty cool scientific article. We're going to read this out loud. We're gonna, I call it popcorn. We're gonna take turns reading this. So, understanding the science behind this will actually help you make better ice cream. All right. Mac and cheese, would you read us the first two paragraphs?
Huh? Oh. If you think about it, an ice cream is actually quite a complex,
Multifaceted.
multifaceted composition. It should be solid yet soft, and should be I can't really read it.
Is it hard to see? You can
Yes.
come up here and read it if you want. Can you guys all see it okay? Okay.
I have bad eyesight.
No, that's okay. Come on up closer. And don't worry about the words, you guys. Just do your best, okay? Preferably.
Solid yet soft, and you should preferably stay that way. While melting slowly, if you would simply put a batch of cream in the freezer, you would not end up with ice cream, but a block of hard frozen solid cream. The reasons for this delicate and mesmerizing nature of ice cream is ultimately a matter of food chemistry.
Awesome. Great job. Thank you. Greg, you're up. Molecular gastronomy.
Molecular gastronomy has been quite popular in recent years. Understanding something about the physical and chemical aspects which turn your ingredients into delicious ice cream will not only add to general knowledge about the world, but will also give you something to talk about over your next scoop of ice cream. Most importantly, however, it will help you prepare your own ice cream in a better, more mindful way, drastically increasing your success rate in the kitchen.
Okay, so what goes into ice cream? You guys called out a whole bunch of things earlier. It was awesome. We have ice crystals. We have fat. We have sweeteners. We have air. Air is very important. Actually. Air. Yes, it's the invisible and the most affordable ingredient. And we have other solids depending on what you add into your ice cream, okay? So, did you ever think about air being in your ice cream and how important air, what part it plays in making your ice cream? Huh. Who wants to read this one about air? Let's read it. Alright, Sophie, thank you.
The invisible and cheapest ingredient in ice cream. The tiny air cells whipped into the base mix are largely responsible for the general consistency of ice cream and greatly affect the texture and volume. Overrun is a technical term used to indicate how much air ice cream holds. Since air is free and increases the volume, non-premium commercial ice creams could have an overrun. Sometimes, even exceeding 100%. having one scoop of ice cream with low overrun could therefore equal the actual content of two to three or more scoops of ice cream with a higher overrun.
Awesome. So isn't that interesting to think about air being an ingredient?
Really interesting.
Very interesting, right? Okay, so this is the cool part about this class. We're gonna, stop reading this and we're gonna go into all of these details about the ice cream, but I wanna show you something, the chemistry of ice cream.
Oh yeah.
This is what we were just talking about with the ice crystals and the fat and the sweeteners.
There's a whole entire college course about it.
There is a college course, and I can give you guys the link if you want. The course hasn't started yet, but there is an entire course on making ice cream.
No, there's two.
There are two. Well, there's two, there's probably more than two.
I don't
So,
know,
but there's two on, and I put the resources on the Schoology page, on an article if you guys want to know more about it. But I want you to know, it's not just shaking a bag up with some ingredients. I mean, it is, but what's happening with those ingredients is very important. It also has to do with different molecules, sucrose molecules. It has to do with how they bond together. This is all part of ice cream. Okay, so basically, ice cream is chemical energy and a few ingredients. I just want to give you a little history. Ice cream has been around for a very long time, for over 100 years. We, as Americans, have the absolute highest consumption rate of ice cream. We eat more ice cream than anybody else in America. Are you guys surprised?
No.
It's so good. Okay. It became popular and affordable after the invention of the hand-cranked ice cream machine. So some of you said you made ice cream at home. Now maybe you put some in the freezer and you turn on something that's electric, or do you guys hand crank it?
It's electric.
It's electric. Boogie, boogie, boogie. Okay, so there are hand crank ice cream machines, and that's how they started. They did start with somebody by the name of Nancy Johnson. Thomas Jefferson is famous for introducing ice cream to the White House. And so he brought it into the White House, and that's kind of how we started. Well, ice cream got to be so popular, so the story goes. Some people said he is responsible for introducing the recipe, but it's actually this Nancy Johnson lady. He brought it to the White House, and it's been a popular treat ever since.
Did he also introduce mac and cheese?
He's done all kinds of cool stuff. I would have to look it up, but I don't know off the top of my head, but it's possible. Before, ice cream was only something if you were very wealthy, you're the only ones who would have it.
You
But
have to be rich to have ice cream?
yes, because the ingredients involved.
Dairy
Yeah.
is expensive.
And ice.
Still
Think,
is.
we didn't even have
Ice.
freezers or refrigerators, right?
True.
Dairy, sugar, think of what's involved, and there was not a lot of extra around. So isn't this interesting to think about?
Mhm.
And we take this for granted. So it's so easy. We go to the store and buy everything we need, right? Used to be only for the wealthy until they came up with this hand crank and it became more affordable where you're mixing sugar and salt. Ice cream gets its creamy texture from the way the fat molecules and the air bubbles bind together. And if you freeze it too fast, or don't freeze it long enough, that's gonna make a difference in how it tastes. So some of you said, you didn't like that one type of ice cream, maybe the texture. Maybe it was frozen too fast and had a different texture, and it's not a texture you like. So who knows? There's a lot of different things going on here with the ice cream. Anyway, ice cream is pretty awesome, and I think it's a great way to have a science lesson. So we are going to go over some expectations. So anytime we have an experiment in our classroom, we have to be mindful of a few things. Number one, you guys are all going to get a bag to make the ice cream. If you don't like ice cream, you don't have to make the ice cream. You don't have to have a bag, it's okay. Just let me know, but everybody will have the opportunity if you want. We must be safe at all times. COVID means we can't be sharing the ice cream. We can't even share the bags, because you're going to be shaking the bags, unless we wear gloves, so we can do that too, so we can talk about that. But we have to be careful with our safety. We have to keep clean, right? Be mindful of that. Cleanup. Part of your grade in this class is actually cleanup. We have to put everything in the trash, wipe down tables. We don't want sticky or rotten milk in this classroom. No bueno. That would be really bad. So part of your grade is cleanup. There's trash cans over here. If we're outside, I'll show you where the trash cans are there. And then science is fun, but we have to make sure we pay attention. We always have to pay attention to what's going on and what's happening. We have to make observations and we have to learn from the experiment. It's not just making ice cream, being I got ice cream is, ooh, what happened? Why did this happen? Why does Sophie's ice cream look different than Gray's ice cream? Why is this ice cream really liquidy and why is this one really thick? So I want you to observe what's going on. Does that make sense? Any questions about the expectations for what we're doing today? Everybody's okay so far? Awesome. Okay. We are going to, this is the ingredients list. So you guys just look through it for a minute so you know. I'm going to walk you through all this, but you're going to use half and half. Where did that go? Over here?
It's on the bottom.
It's on the bottom?
Yeah.
There we go. Okay, so everything is on this card. Thank you, Sophie.
Caitlin was the one that helped you.
Got it. Okay. So we have the half and half. You're going to have sugar, vanilla. I also have mint if you guys prefer a peppermint ice cream. You're going to have sandwich bags, 2 different ones. You're going to need a small bag and a big bag, okay? The big bag's going to have the ice and stuff in it. The small bag is going to be actual ice cream. You're going to have salt. We have a bunch of salt here. We're going to have ice. The ice is in that bag over there. If you want, you can wear gloves. We're not sharing, but if you are concerned or you want to wear gloves, the gloves are right here. So please know that you can also wear the gloves. And then I have plastic spoons for everybody. They are individually wrapped. So there's no chance of sharing anything crazy. So you just take off the plastic, throw it away, and then you have a spoon to eat. You need to finish this ice cream up before we go. You don't really want it melting throughout the day. Does that make sense?
Gotta eat ice cream fast.
Ice cream, eat it fast, don't get a headache. Okay. Any questions about any of these ingredients? Anybody have any concerns about any of the ingredients? Oh, I also have chocolate chips. If you guys want to add some chocolate chips in.
What flavor did you say?
Vanilla and mint. Okay. So, I know not everybody likes the same thing, so make it yours. It's gonna be yours. Right now, we're gonna talk about what happens. What are these? Let's go over those definitions we talked about earlier. So what temperature does fresh water turn to ice? Who knows?
2 degrees Fahrenheit.
0 degrees Celsius.
32 degrees Celsius. And-
What?
0 Celsius.
0 Celsius.
Right.
You said Celsius.
I did say that. You said it right the first time. 32 degrees Fahrenheit, 0 degrees Celsius. That was funny. Okay, so what happens?
Cold happens.
Cold happens. How does cold happen?
Ice and movement equals friction equals cold equals ice cream.
Okay, so let's talk just about water for a minute. I like all the words you're using. I think that's pretty awesome. So what we have is the freezing point. Freezing point. That was one of your vocab words, right? So the temperature at which fresh water freezes is the freezing point. The freezing point is the temperature at which a liquid turns to a solid. Take a minute and write that down. Write down 32 degrees Fahrenheit and 0 degrees Celsius because this is the freezing point of water. Again, this is when the liquid turns to ice. So the freezing point is temperature when a liquid turns to a solid. 32 degrees Fahrenheit, 0 degrees Celsius. Turn and tell a neighbor what freezing point is. Anybody nearby, just tell somebody what the definition of freezing point is.
Freezing point equals the temperature at which liquid turns into a solid.
Arden, you can tell Mariah, or Mariah and Sophie, you guys can share. Gray, why don't you guys share too? So some of you, the way you're sitting, you might have to say it more than once. So Mackenzie and Gray, why don't you share what freezing point is?
I'm not going to say
Slightly, but sure.
That's true. Okay, any question about freezing point? No? Okay, so we're gonna be seeing this happen today, right?
Yes.
Okay, why do we add salt?
Endothermic reaction.
Okay, so what, why? Can I just put
colder?
milk with ice and shake it up and be okay?
No.
Are you sure?
Maybe.
I mean, I make milkshakes at home and that's what I do.
And bring out the boys to the earth?
Huh?
Bring out the boys to the earth?
Get out.
So why do we add salt? Have you ever driven on an icy road in Colorado and we put salt down on the roads?
It melts it, right?
Friction.
Okay, so something very interesting happens.
I don't know what that means.
We add salt to lower the freezing point. So we just said what the freezing point was, right? So freezing point is what again?
32 degrees Fahrenheit.
Okay, and what is it? Is when a liquid turns to
Solid.
a solid. So if we add salt, we're going to lower the freezing point. So that we don't have ice on our roads. That helps to make sure we don't have ice on our roads, right? And in making ice cream. So this, you were absolutely 100% right, is an endothermic process. This ice absorbs the energy. Anytime energy is absorbed, that is endothermic. So here's your next definition, endothermic. Endothermic process absorbs energy. Absorbs energy. So this ice absorbs the energy. The heat is transferred. The heat's transferred to the ice. And it makes the mixture colder, and hence we get ice cream. So this is an endothermic reaction. Does that make sense?
Yes.
As we're going through this, and as you guys are making the ice cream, I want you to use these terms and explain to me what's going on. So basically, you're going to tell me how the ice absorbs the energy and the heat is transferred. Any questions about this? Okay. Can we control how fast the ice cream forms?
Yes.
Yeah, how? What can we do?
More or less salt.
Change the salt. How much salt? Very good. Because we know that salt changes the freezing point, right?
Yes.
So we can change this. Just modify the amount of salt. We could also modify perhaps maybe the different types of salt. There are a lot of different types of salt, right? We're going to use rock salt and ice cream salt, and I have kosher salt.
Kosher.
So we have different types of salt. So we're going to use different types of salt. Rock salt has larger crystals, and it takes longer to dissolve, which may mean we have a smoother ice cream. Something else has smaller crystals. So this is where the texture comes in. The way people make ice cream, you know, Ben and Jerry's, Dairy Queen's a little bit different. No, they're all the same. They all basically have the general same principle, but in how fast we make it, what type of salt we use, or it's not all salt. So there are other mechanisms we use to make ice cream. It all depends on what the texture is going to taste like.
It goes in the machine like when it comes out ice cream.
It's like magic, right?
Yeah.
You pour in that bag of ingredients, it cools off, and then voila. You have your cone.
Ice cream before? So cool.
Which kind?
Stretchy ice cream.
Stretchy ice cream.
Yes.
Where's that from?
It's from,
Belgium?
I think it's Turkish.
So what is stretchy ice cream? I don't think I've had that.
You like,
It's ice cream that stretches.
ice
Like
cream that you add
taffy?
like that you add like a root compound, I mean like some root powder to, and then it like stretches.
Okay.
And you have to cut it into logs.
And does it melt?
Not quite as fast from what I've seen.
So you're adding another ingredient to change the chemistry of it,
Yeah.
right?
It's stretchy and it looks really cool.
That's super cool. So let's make our ice cream today and think about what you learned with the stretchy ice cream and the ice cream today, and compare maybe what we think some of the ingredients are and what's going on. Okay. So ice cream is also a compound. What does that mean? Anybody know?
It is multiple ingredients put together.
Chemicals.
A mixture of two or more chemicals. That's all it is. So, a substance formed from two or more elements, chemically united in fixed proportions. So, a compound is a mixture of two or more chemicals, two or more elements, chemically united. So, once all of the ingredients in our ice cream are mixed up, they're bound together. And I can't just say, oh, I'm going to take out the sugar and just drink the milk. Can I do that? No, because once we mix them, they are bound together.
Because it'll dissolve.
They are chemically combined. Now, we could separate them. We could, but that would be another chemical reaction. It would take some other steps, right? All right, so we talked about the definitions, endothermic. We talked about compound. We've talked about the ingredients. We've talked about everything from air to ice crystals and how and what goes into ice cream. We're getting really close, you guys, to trying this out. Melting is an endothermic process. You guys learned that. But what about freezing? Somewhere things have to freeze, right? So freezing is an exo. Exo meaning like, what does exo mean?
Exit.
Like exit. So freezing or crystallization is an exothermic process and heat is evolved. So we are going to have heat absorbed and heat released to make our ice cream. And the big fancy word of thermodynamics.
The heck is that?
That is these processes right here, the melting, the endothermic and exothermic.
Thermodynamics, oh, it's right there. If I would just read this.
So
to you-
what thermo, you didn't know what that meant, but could you figure it out just by breaking down the words?
Yes.
Right, so therm means
Temperature.
heat, temperature, so you know this has something to do with temperature, right? If you don't know what something means, break down the words, and you will completely understand what's going on. At least you'll have a place to start, right? Okay, you are gonna have homework, but it's gonna be pretty simple. You just have to have 5 examples of each type of reaction, so 5 endothermic and 5 exothermic reactions. And then, if you can come up with a way to make ice cream better, let us know. Think about it. So an example of, you guys, in the wintertime, have you ever had those packs of hand warmers where you
Yeah.
shake them and you smash them and then you have instant heat? Okay, that would be an example.
You just submitted on school with me?
Yep. That's an example of these reactions. So I want you to find 5 of them. Endothermic, 5 exothermic, and submit on Schoology. That's your homework for today. We went over those definitions kind of quick. How do you guys feel about it? What is endothermic?
In.
Absorbs or releases heat? Which one?
Absorbs.
Absorbs heat. What is exothermic?
Expulsion of heat.
Excellent. What is a compound?
Mixture.
A mixture. And can we very simply just take all the ingredients apart?
No.
No.
No, there has to be some other kind of chemical reaction, right?
Correct.
Okay, any questions about the science behind all of this? It's a very basic science, but if you guys say go to work at Ben & Jerry's or Josh & John's or Dryers or Bluebell, this is somebody's full-time job to make sure the ice cream is amazing. So all of this and the chemistry of ice cream can get very complicated. Today I just want to introduce you to it. And now the best thing for us to do is to try to make some and talk about everything we just learned. Are you guys up for some ice cream?
Absolutely.
Okay, put all your notes away. Excellent. I'm going to put the ingredients back up on the whiteboard. Okay, so with COVID, really, I'm the only one who can touch anything. I'll put gloves on. This can be a little messy, so you have to be careful. You have to be very careful and make sure your bags are sealed tight. That is the number 1 rule here. Make sure your bag is sealed tight.
That's something that kids do though, so after they worked in my paper, wasn't exactly so tight and then they had salt on it.
And your ice cream tastes awful. It tastes like salt, right? It also can get on the floor and the carpet. So if we find out that we're making a big old mess, then we'll take it outside to shake. You're gonna we're gonna put all these ingredients in the bags, and you guys are gonna shake pretty vigorously for like 5 to 7 minutes. And then you'll have ice cream.
Yay.
Okay.
Okay. So, I'm gonna hand out some Ziploc bags. I'd like you all to, I don't think we need to put our names on them because we are gonna throw these away as soon as we're done. Does that make sure your computers are somewhere very safe. I don't know that you want them on your desk. Make sure they're in your backpacks or your bags. Just in case something should spill, we certainly don't want to ruin any computers, right? Right, here we go. All right, who wants ice cream? Yay! You guys want to go wash your hands down in the bathroom really quickly?
Sure.
Even though you're meeting with a student and stuff, why don't you all go wash your hands, leave the door open, and then come right back and we'll get started.
We good children
So,
here.
can I just put on gloves?
You can, yes. Yes, sir.
Can I just watch
Actually, you know
this?
what?
Yes.
I don't want to watch.
Yeah, you guys do not have to make the ice cream, you absolutely can just vibe. In fact, do you wanna help me, Zaylin? Do you wanna be a,
Sure.
since you're not eating the ice cream, well. Alright,
Yikes.
Tiny little glove.
they are tiny.
Extra small.
Alright, we need the quart size.
That's interesting.
Do you guys all wanna help since you guys are?
You might be the.
You're the leaders of the class?
Highly
debatable.
I just like
Okay.
ice cream.
Do not give me that look, Zane.
Do not, okay, here we go, guys. Half a cup of sugar, so. Who wants to be in charge of this sugar now that you have your gloves on?
Hold on.
Go for it.
Gloves are not working right now.
Okay, as you can see, everything's kind of laid out on the table. You guys do not have to wear gloves. I'm wearing gloves because I'm gonna be,
I'm wearing
Touching
gloves
the
because it
food.
hurt because it hurt my pinky. It started bleeding and no.
we don't want that. Okay,
Bloody ice cream.
I need everybody
Yes,
to
dude.
grab a quart bag. So the smaller bags over here, everybody grab one of these.
Yes.
Once you have your bag, please come over here.
A small bag.
Small bag, they're over here. Okay, I have to get the right measurements, but I do not have the right.
Well, if you have to.
Sugar. Vanilla, half and half, okay. Alright, you okay, Arden? Ow! The gloves are small, huh? Okay.
I don't understand.
Ew. My finger looks so bad.
Alright,
After these gloves go on, they're not coming on.
they're not, that's funny. Alright, come get a bag, everybody get a bag. One small bag,
I don't wanna wear this.
one
man.
small bag.
This is not it.
Zaylin, how do you feel about pouring? This is a half a cup.
If I
And
put my hands
everybody's
are
back.
sweaty, this one
Are you
looks
okay
even
with that?
better.
You can say no.
Mommy.
Okay, so here we go. Half a cup, and you guys, after you have your small bag, go see Zaylin. He's gonna give you half a cup of the cream. I have four, we might want to over this table, guys,
I got one on.
in case we spill it over this paper towel. Alright, line up, you guys remember you have to be safe. So Zayla's gonna be on this side of the table, you guys are gonna be on that side. He's gonna give you half a cup of cream. How about if you all line up against the window and we're gonna make an assembly line? Yes, please grab that.
Assembly.
Yep.
Where's the next assembly?
Okay, then you're gonna come over here. Got a bag? Awesome.
I only have one glove on.
I'm gonna give you some sugar.
One tablespoon.
Wait a minute. Where do we go?
One tablespoon of sugar.
You get a bag. Where is a bag? Oh, bag is over. A bag is over where?
Oh yeah, it is like oobleck.
You're a doctor.
Okay.
No, my hands are wounded or something.
There's some sugar. Okay, I want you guys to add your cream and sugar. Move down to this next table. If you guys do not have your cream or sugar yet, please come right over
Where
here.
is the first step of us having a
What's that?
If you replace this with coffee creamer and make ice cream,
Oh, I bet that is good.
Oh, yeah.
I like that. I wonder if that would change the texture or anything, or it's just,
it just, it doesn't.
is it flavor?
It, yeah,
Smells like to me.
the flavor, it doesn't really do
Oh,
anything.
God.
Having to do with they don't have your right size glove and your gloves are also provide plus hours.
Okay.
These actually fit my hands, so I'm good.
It won't let my hand be all the way open.
I feel like I should let you do the sugar and the cream. How do you feel about that?
Just put milk in the
Who
glove.
doesn't have one?
I need one.
Alright, you guys, now,
Where do I get a bag from?
I'm gonna do some vanilla. So Zaylin's gonna give you guys, sugar and the cream. Then you're gonna come over here, and I'm gonna give you the vanilla. Yes, ma'am?
Where do you get that from?
Oh, right here on this table, so have one of these.
One peppers or just?
One tablespoon. So use the red. Yeah. That would be amazing, the amount of sugar. Okay, guys. This is not colored as far.
And then why will you leave the back?
It's not, it's not cooperating.
This is uncomfortable.
Okay.
There's just like a glob of sugar
Yeah.
in
There's a lot of sugar. These blobs are fun. Alright, here we go, quarter teaspoon of vanilla. Oh, there you go, perfect.
I add some more apparently.
Perfect.
Oh,
Good enough. Does anybody cook precisely? Are you guys cooks?
I do not cook precisely.
Are you
I
precise or
follow.
you
A
just
pinch of this, a pinch of that.
pinch of this, pinch
This
of that?
much of that.
Do you think it's important for us to measure everything exactly?
Literally no one my Italian grandma was cooking. A pinch of that dumps the whole thing.
Uh-huh.
You can't let
Yeah,
salt
let's add
into
a
your
shot
diet.
of vodka.
Oh, no.
Mom,
Okay.
Jenna watched the recipe and then
And
she
then
does that. And
shot
then
Go
of
ahead and close up, close up
No,
your,
so it's on like a cooking show.
Bag.
She goes, and now add a shot of vodka, and then she does a shot.
close up your face, that's pretty awesome. Close
Maybe a
up
little
tight.
bit more.
Wait,
Close up
so
tight,
we have milk, sugar, vanilla, and that's all we need in
in your small bag.
For basic ice cream, yes.
Okay, make sure that it's sealed tight.
Oh, okay.
So get all the air out of it, you kinda need to like squeeze the air out, it's very important, squeeze out as much air as you can.
In fact,
Air, what if I want more ice cream? Have we more air?
You need, so air is important, we learned air is very important, right?
Yes.
But if you have too much air in your bag, it's
do
gonna
we not
pop.
have duct tape? So you could just
Duct tape
it
does
shut.
work, we could use duct tape.
Just to duct
But,
tape it shut.
Okay, so everybody, super tight, you got all the air out, that's great job, Mariah. Great job, Taven, Arden, good. Okay, you got all the air out? Now, I'm gonna give you guys,
It's horrifying.
you're gonna put it in here for safety. So put that bag into another one of these. And this is because we're inside, we're gonna take this precaution.
Okay.
Okay, so put this bag into another bag and do the same thing. Good job, team.
Okay.
Okay,
Yes.
then you're gonna put both of these into
Big bag,
a gallon size bag.
big bag.
Yeah, these gloves are not gonna be able to come out.
You'll be okay. You guys don't have to look really much. Okay, guys. Alright, now put this into a big bag.
30 years later, we're trying to get that.
Big bag, Arden,
Big bag, long story.
see what I need from
Time
this little bag?
you're making ice cream. They never came
Here you go,
out.
Gary. Here you go, Riley. Okay, now you should have one big bag full with your two little bags. Everybody's good? Okay, don't close the big bag yet. Now we're gonna add some salt to everything. I'm gonna use this one. Okay. So what does salt do again? Why do you,
What is the freezing point?
it lowers the freezing point. Why does that?
Yes.
Cause it makes the ice.
And just say,
Hold
as
it,
soon as you
right?
figure out how to get the bullets.
Oh, not supposed to hold it yet.
Yeah, it's super
Okay.
Should never.
It's just.
Zaylen's gonna give everybody a quarter cup of the salt that goes in your big bag.
Salt.
Salt.